Howdy folks, got another update video on the 10 horse Allis-Chalmers motor and the phase converter build. As you can see, it's getting together. There's still some details, but it's the basic idea is apparent now how it's going to be. The contactors and relays are in this box. The boost capacitors and the run cap banks are on top here, and then we have the control station for it. So what I'm missing is the outlet box. It's going to have an outlet box back here for the output, and temporarily I just have this hardwired. Also, this red wire is for checking the input current, so that will not be there permanently. But later on I'm going to hook up the clamp meter around that to show the current draw. So I'll open this up. You can see the massive amount of yellow wiring in there for the cap bank, which is functional. And then you can see the black and white wire with that floating terminal block. That red wire is just a loop in the cord, one of the input lines from the cord. Those two big wires right there, they are part of that cord that's plugged into the wall over there, the 240 volt outlet. So I think the last video there were some parts not installed in this, and it's all here now. So the magic, if you will, that helps this to work is in the two potential relays. There's a black box right there and then a white one there. And what those do, they monitor the voltage that the motor is producing on the B phase, the derived phase. If that voltage is too low, then those two relays will turn on one of those two contactors. And the black relay operates at a lower voltage, so it has to either be powered off or a really extreme heavy load to activate that one. And then this contactor over here is for the start capacitors, and those are the electrolytic black case electrolytics back there, and they provide a tremendous phase shift in starting torque, but they can only operate for a few seconds at a time or they burn out. So that part of it generally works once on startup. Then the other contactor over here, 2-pole, that is for the boost capacitors, and that's part of this bank up here. So that potential relay, it doesn't have to lose as much voltage. It has to drop down to about 160 volts on the drive phase, and that'll kick in the boost capacitors, and they will stay in the circuit until the voltage is fully recovered to above 240. So generally the boost capacitors stay on whenever an external motor is running. Now if I start the unit, you'll be able to see first both of them will pull in at once when the motor starts. Then you'll see the start cap one turn off, and then the boost cap. So here goes for a start. So as the voltage built up, the first potential relay to drop out was the start, and then the second one to drop out was the boost caps. That's how that's supposed to work. It's doing what it should. Now the two silver can capacitors in there, those are the input corrective caps, and those basically adjust the power factor on the input side. They're in parallel with the main winding of the motor, which is receiving single phase power, and they provide the magnetizing power, the reactive power for the motor to run. So I'm going to close this box up and do some more function tests to show how the controls work. Okay, the clamp meter's on the input power to the unit, and when I start it, we'll be able to see the current draw of the motor coming from the line, the 240 volt line. And then over here, this little connection point to this small cable, that is the remote output control switch. They'll let me remotely turn the output contactor on and off. And if this switch is in the remote position, then that remote switch is active. If it's turned on, then the output is on all the time. And for a load, I have this 10 horsepower Brook motor hooked up. So when I push the start button, right here we should see the starting current, and then it'll drop back down to the no load running current. So the whole machine is taking 2.8 amps from the wall at 240, and then I'm going to turn on the output and send power to that 10 horsepower Brook motor, and we'll see the current demand of that motor. Motor has such a cooling fan in it that the shop fan over there is blowing from the wind. The air is blowing out of that motor across the floor and turning my my old 423. I'll turn the output off. That motor is quite dangerous. There's 2 bolts in the end of that pulley. It's a solid cast iron pulley, so it's great for a load test because it has a lot of momentum. But those bolt heads would be really completely dangerous if clothing got wrapped up in them, so I'm not going to go anywhere near that. You can see the oiling system working. See the oil drip falling down in there. Exposure may not be good, but it's right in the center underneath the bearing. So if I put this in remote, then that will make this switch active. So if I had a reason that I needed to work on something and not have the sound of the converter, I could use this. So here we go. Started that motor. Output lights on. I can turn it back off. So far, functionality is doing just what it needs to do. I took the cover off the bearing so we could see the oil ring working inside there. And you see that ring that turns when the shaft moves. Well, when the motor starts, that'll be picking up oil and lubricating the bearing. So here we go for a start. Dripping off down in there. It actually goes all the way through the bushing and circulates, falls back in the oil sump. Very simple but very effective. I've been on the internet doing YouTube for quite a while. And there's always multiple differing opinions, and I generally just ignore people's opinions when they seem to be showing a certain level of ignorance or aggression, I guess. And I always try to see things from someone else's perspective and not try to see those ignorance and aggression in what people say. But sometimes it's just obvious that's why they make their comments. Now, I haven't done a whole lot of electrical equipment videos up until recently, and in the past I've done some auto air conditioning and other air conditioning related videos that have I've had to make them where the comments require approval because too many people are expressing their non-constructive criticism and really juvenile opinions. And I realized that this build of this phase converter on this motor is starting to get a few of those non-constructive comments. And what I think it has to do with, I don't know, it's hard to say. It's hard to say. And you'll recognize the comments when you see them. But they show ignorance mainly, and like the ignorance is being covered up with aggression, try and hide the fact that they're ignorant. So if that kind of thing keeps on, then I'm going to have to moderate the comments a little more heavily, because this is a project that I wanted to do just because, and no real reason, because this motor is really neat. I like it. It's rare, and not many of them around that still work. So to me, it was worth the time and the money spent on it to make this work. Now, it would be much easier and cheaper to go out and buy a phase converter. Absolutely, no doubt about it. But that's not what I want. I wanted to put this motor to use and build another phase converter out of it. No other reason than that. And you know, if somebody doesn't want to take the time to build something, then they should go buy it. And this is not something that's going to be run constantly. It's a test tool, so to speak. When I test equipment in the shop without three-phase utility, I'll need this for testing other equipment. So it's not something that's going to be run daily or in a commercial environment. It's only for testing other things and just to have something neat. So another couple things that are not doing things the easy way, but doing it the way that's really neat, in my opinion. You can see I've got a couple of really big box fans here. Now this one on the right with the black fan blade, this is a Sturtevant fan, and it's been documented online in the AFCA forums as well. But this thing was made in 1925, and I contacted the Sturtevant Company historical website, and there's a gentleman that runs that, and he was an employee of the company for years, and he confirmed the date. This was from 1925, and there were two of them. One of them I built on commission for somebody else, and this one I built for myself. And they have a VFD inside this little wooden compartment in the corner. It's an older Allen Bradley 160 series. 120 volt power comes in there. The transformer in the corner, that steps it up to about 480 volts single phase, and the VFD powers this motor, and it is a three-phase motor. This is by far the best, most convenient way to run one of these big fans, because it doesn't have to be running at full speed. This is the start control, and this is the speed control. It's analog reference to the VFD. That's about 50% speed. But these direct drive fans are nearly silent. And this one's seen a lot of hours of use, that's why it's so dusty. It's moving a lot of air. Then of course push to stop. This is another journal bearing motor, which this one has wool packing instead of oil rings, but it is journal bearing. This one here was my first big industrial fan build, and it uses a similar design. There's another 160 series VFD under that cover, and a step-up transformer, 3 kVA, 120 to 480, to run this motor. And I can't get to the controls on this one. I've had to push a bunch of stuff in the shop for the wintertime. But it is a bucket blade ILG, and this sucker's really powerful. Its factory rating on this motor was 1.5 horsepower, and the VFD can push it up to about 2 horsepower before it exceeds the rated current of the motor, and it will really turn this building into a wind tunnel. These fans are awesomely engineered. It's a piece of art, basically, and there's definitely nothing like it today. One more neat old thing for the antiques guys. Most of y'all have seen this before, but this is my 1926 Frigidaire M52, fully operational. Keep water in it. Now, this is unlike any modern fridge. I guarantee, unless you watch the video on this, you haven't seen a fridge with a compressor or a condenser like that. This one has a Century repulsion start induction motor and the open coil condenser. Now the system is controlled based on pressure on that bellows, and that's actually the motor contacts there, so definitely you don't want to touch it. The single cylinder compressor. I think that it's missing a grill on the back, but I never had that part because obviously the belt is exposed back here, and it'll kick in any minute. So, you know, the same reason that I wouldn't go out and buy a phase converter, that's the same reason I didn't go to Lowe's and buy, you know, $100, you know, beverage fridge to keep out here. This to me is what it's all about. I want to have something unique like this that is just important. You know, there's very few of these left that still work and are used, and I want it to work like it's supposed to and know what it sounds like and how it would have been back in the day. And it's worth the extra time and effort and money for me to have this working, instead of just take the easy route and go and buy, you know, a $50 or $100 fridge at Lowe's. This is what I want. So somebody had asked about a schematic for this, and I drew one up in AutoCAD, but I wanted to make sure that it functions as intended, as the schematic was drawn. And I'm reasonably confident that this is working correctly, so I will share that. And you know, your mileage would vary significantly, because this old motor has really different reactive power characteristics than anything modern. So you're going to need to throw away these capacitor size information from the schematic, and probably the potential relay voltage set points. And another thing about the potential relays, they are, you know, GE Mars relays, but they have absolutely been modified. You will not get them off the shelf with the ratings necessary. So go ahead and just don't try to look at numbers or anything off of this build. You'll have to look them up on the chart and see what's closest, and then make adjustments. So I'll try to post a link to that schematic, maybe not tonight, but soon. We'll go for one more start of that Brook motor and see what the startup current is on it. I saw 170 amps go by. Alright, now I'll go ahead and stop the converter motor. You can see how the rotor's not running true in there. This old motor's had a hard life. But for something that's just used as a piece of shop equipment, I think it'll last me quite a while. Got a good coast down time on it. I'm going to close that to keep dust and dirt out of there. One more thing I've got to get is a cap to go over that bearing. on the back. Alright, that's going to be it for the video. I'm surprised at the amount of interest that this old motor and phase converter build has had. That's great though. I love it when people are interested in old stuff and want to learn about it and kind of keep our history alive, so to speak. And again, thank you so much for watching and for the constructive comments. Keep them coming.